In this lesson, we will cover questions from Unit 5, Section 5.6, Properties of Linear Relations. Question 1. Which table represents a linear function? In order to determine if a table represents a linear function, we have to see which table has a constant increase or a constant decrease of the y values. So when we look at each table, we're going to look at the difference between each element and see if it's constant, and if it is a linear function. If it's not, therefore we can say it is not an option for this question. So if we look at the first one here, from 2 to 6, we're adding 4. 6 to 10, again, we're adding another positive 4, and a positive 4. So our first one right off the bat here has a constant increase, check. So that would be the solution. But let's look at B, C, and D and look at why they are not linear functions. 4 to 7, we're looking at a positive increase here of 3. 7 to 12 is positive 5. 12 to 19 is positive 7. 19 to 28 is a positive 9. So if we had to look at it, it is not going off by the same term all the time, therefore it is not constant. It's constant here because each one is increasing by 2, but we need the first level to be constant. So that one there would not be an option. Part C, 4, 8, 16, 32, 64. Maybe right off the bat you will notice that each one is being multiplied by a multiple of 2. So 4 times 2 is 8, 8 times 2 is 16, and so on. So that would not be a linear function. 25 and 24, we're looking at this one is going down. So it's first decreasing by negative 1, then it's decreasing by negative 2, decreasing by negative 4, and decreasing, or negative 3, and then decreasing by negative 4. So that would not be a linear function. So the only option here that has a constant increase would be A. Question 2. Determine if the graph below represents a linear relation. So unlike the table of values that we had in the previous question, a graph, we can look at it in two different ways. We can look at the shape of the graph. Is it a straight line? Or we could quickly use the vertical line test, where the vertical line that is drawn through the graph can only hit the graph at one place. If it hits at more than one spot, it is not a linear relation, it is not a function, or is not a function. So let's check to see if what we have here. Well, certainly the graph is not going to be continuing in a straight line. All of these points here lie in a straight line, but we have this one here and this one here is kind of put off by itself. So let's take a point. So let's try a vertical line through here. Sure, that vertical line hits that graph in only one place, but we can't quickly assume that it is a linear relation or a linear function because we need to see if the whole graph will hit only once. What if we drew a line through here? If we drew a vertical line through there, you can see that it hits in two places, which can't happen. And we're going to look two places again. So since this vertical line test does not pass, it is not a linear relation.